For section 3, we're going to cover questions 7 through 10. So let's go ahead and start by taking a look at 7. 7 says, an arithmetic sequence has a recursive formula below. F of 1 equals 1/2. F of n equals f of n minus 1 plus 2. Determine the first 5 terms of the sequence. 2 hands. Thank you. So we know that our first term is 1/2. This basically is saying add 2 each time. So we're going to say 2 plus 1/2 is 2.5. Then we're going to say 2.5 plus 2 is going to be 4.5. 4.5 plus 2 is 6.5. And 6.5 plus 2 is going to be 8.5. Now, some of you may have chosen a different route to go through here. You could have done 1/2, 5 halves, 9 halves, 13 halves, and the last one would have been 17 halves. This would have been making them improper fractions. Here, I just made them mixed numbers. It says, write the explicit formula for the sequence using function notation. Now, let's recall what function notation says. Explicit formula says. Explicit formula says take A1 plus your common difference times n minus 1. Okay, so in this case, we're going to do A1, which is 1/2, or f of 1, same thing, right? So 1/2 plus, what's my common difference? What am I adding each time? 2. So 2 times n minus 1. And this is what f of n equals. Now I can simplify this, so let's go ahead and do that. I got 1/2 plus 2n minus 2. 1/2 minus 2 is going to be negative 3/2. So this would equal 2n minus 3 over 2. Number 8. If arithmetic sequence has an explicit formula of a sub n equals 3n minus 8, what are the values of a1 and a2? Well, a1 is where we're going to plug in 1, right? And a2 is where we're going to plug in 2. So we're going to say 3 times 1 minus 8. That's going to be 3 minus 8, which is negative 5. Here we've got 3 times 2 minus 8. So that is 6 minus 8, which is negative 2. How can you use these values of A1 and A2 to find the common difference? And what is D? Well, the difference is how to go from one number to the next, right? Well, if my sequence goes from negative 5 to negative 2, how do I find what the value is of D? D should be equal to A sub 1 minus, should be A sub 2 minus A sub 1. So A sub 2 is negative 2 minus a negative 5. So we've got negative 2 plus 5 equals a positive 3. So to go from one number to the next, I'm going to add 3 each time. So our common difference is 3. Pardon that. Use your answers from parts A and B to write the recursive formula for the sequence. Now remember with recursive formula, we have this brace and we have A sub 1 equals, and then we have A sub n equals something, okay? Well, let's recap. A sub 1 should always be our first number. Our first term in this sequence is negative 5, actually. So a sub 1 equals negative 5. A sub n, remember, if you recall from the previous page, let me pull that back. We always want to do a sub n minus 1 plus our difference. So we've got a sub n minus 1, and my difference is 3. So I'm going to put plus 3. Let's look at this. It says in the 12th century, Leonardo da Pisa, also known as Fibonacci, first described a sequence known as the Fibonacci sequence. This sequence can be described by the recursive formula below. A1 equals 1. A2 equals 1. A sub n equals a sub n minus 1 plus a sub n minus 2 for n greater than 2. Notice that the first two terms of the sequence are 1, and the expression describing a sub n also applies to those terms after the second term. Use the recursive formula to determine the first 10 terms of the Fibonacci sequence. So this is basically saying add the term before it and the term before that. So my first term is 1. My second term is 1. And then it says take those two terms and add them together. That's 2. To find the next term, we're going to take these two terms, add them together. So we've got 3. We're going to go. So this is 1, 2, 3, 4. Remember, we're going to 10. So we got 5. We're going to go 6, 7, 8, 9, and 10. And remember, it's just a combination of adding the two previous terms. So 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 13 plus 8 is 21. 21 plus 13 is 34. And 34 plus 21 is indeed 55. Let's take a look at the last question. Is the Fibonacci sequence an arithmetic sequence, and justify your response? Now, recall that an arithmetic sequence adds the same number each time. So, is this a arithmetic sequence? Am I adding the same thing each time? Well, here I increase by none. Here we increase by 1. I go up by 2. I go up by 3, and so on. So I'm going to say that no, this is not an arithmetic sequence. Because the difference between two terms is not the same each time. On to your debriefing question here.